So this talk on IEEE 5G6 innovation test was supposed to be before lunch. I hope people can hear me. Anwer, you can hear me, right?
Yes.
Okay, excellent. So our next talk is very near and dear to me and close to my heart. As you might have seen, there has been a big thrust around IEEE, testbed in general, and a power testbed, and you're going to hear more about it also from other institutions. But a few years back, and Anwer can talk about it. So Brad Kloja, who's the program director, he's on site here. Anwer couldn't come. He's in UK. Anwer and I were the volunteer co-chairs. We started this initiative with the initiative committee, and I won't delve details right now. Anwer will talk about it. But good news is, as you can see, we have a picture here, IEEE 5G6 innovation testbed is up and running, and people around the world can participate. And Anwer will say more details about that. So just briefly introduce Dr. Anwer Al-Dulaimi. It's my colleague in IEEE. We have worked together for more than 20 years in different capacity. He's right now the Senior Strategy Manager for Connectivity Industry 4.0 in Veltris, based in Toronto, Canada. He received his PhD in ECE, Brunel University in UK, and Master's and BS degree Communication Engineering. So he also is a prolific writer, faculty, and innovator at the same time, a leader in IEEE standards activities. He's a passionate IEEE volunteer in doing many things. With that, I will hand it over to you. You have 20 minutes to talk about IEEE 5G6 innovation testbed. Thank you.
Thank you. Thank you very much, Ashutosh, for the kind introduction. And hello, everyone. Let me just share my screen from here. I guess this must get much easier. Can you see my screen, Ashutosh? Can you see my presentation?
Yeah.
That's okay.
You can see, yeah.
Okay, so today we will talk about the IEEE 5G 6G innovation testbed platform, and to give you just a little background about the project. So the discussion started actually during the pandemic, when most of the companies decided to move their budget for innovation to operational day-to-day cost, and we thought like creating a platform from IEEE using the IEEE funding would help everyone to back to innovation and back on track. However, from a general image to everyone, there's a problem anywhere with using the testbeds due to the cost. Most of the testbeds are quite costly, and they require a lot of investment, especially if they come from commercial partners. They also limited in functionality adjustment, because most of them, they come with licensing. They have some sort of a shield that prevent people from changing behavior or accessing the code of those testbeds. So there's a problem with the customization. The problem of availability. If you are sharing the platform with other partners, or if you're accessing the platform in a collaborative project, there will be always time constraints on the time and usage and resources availability. And given the fact that most of the testbeds are owned by companies or maybe by certain projects, they limit the collaboration on a larger scale. So it's limited to certain collaborators most of the time, or at least the significant features of them. Also, most of the testbeds are actually meant to serve the purpose of a certain segment or testing a couple of segments of the network. There are limited number of testbeds that allow you to do end-to-end testing from the RAN to the transport to the core of the network, or maybe in a vertical level, from the cloudification level, from the hypervisor level up to the orchestration. End of the day, most of the testbeds are also sponsored by national projects, and there is a requirement actually to have a platform that make it more generic or maybe more neutral to access by different companies and different nations and different technology vendors. So we come up with this idea of the testbed. Our goal, and still our goal, is to get all the operators and the vendors and the application developers all to work together on this platform by supporting end-to-end testing, where most of the components of this testbed is actually located on the cloud, so it's accessible from everywhere. People can use it for different use cases, for conformance testing, for load testing, as a sandbox for innovation, for POCs, for security testing. There are plenty of use cases that we support. And at the end of the day, we can monitor the platform, we can have real-time estimates, and we can see the resource consumption. All those data, as I will show later, are available for you. So you are not just testing against elements, you are able to monitor the overall performance of the network that we have. We also support reduced cost experimentations. This is completely it's a sponsored platform, but we charge very low rate actually for everyone. And if you look at the numbers that we charge them, they're almost like nothing. End of the day, we also the academic perspective to this cycle. So we allow academia to come and use this platform. So we help actually to bring all the ideas from industry and academia all together to work and innovate. And at the same time, we help train both academic staff and industrial staff on using those new functionality from a semi-live network that is up and running over the cloud. So the project is actually open to everyone from industry to academia, and they are welcome to participate. Having this been said, we don't have single architecture for this testbed. We actually have the capability and still maintain different branches with different architectures to be able to have all the visions for the future networks all together and be able to support as much as we can from test use cases. For example, we have a network in a cluster where we support emulator for the RAN and the core. They all contained within one box. We also have MEC architecture in a cloud in a single box in a cluster. We also have physical access points that are attached to our testbed, and they are located in India, in New Jersey, in Johns Hopkins University, and some of them are in the deployment at the IEEE Innovation Hub in California. And we keep deploying different access points across the globe and attach it to our core. We can ping in between those different access points like an operator extended over multiple countries and continents. We also started working on ORAN in different ways. So we have our own ORAN installation in a cluster over the cloud. We also work with Polytechnic University in Montreal, for example, where they have their own ORAN installation there, and we connect that over the internet to our core, which is actually on Amazon. We also work with different partners to integrate physical access points to that architecture. At the same time, we work with our partner operators to hopefully reach to the point when we support semi-live network up and running with physical, real commercial access points or base stations. Maybe we'll have some time here and there on some locations, and we will be able to support some sort of stress testing using this architecture. So if we look at the high-level image of whatever we've been able to do over the last year or so, so we have the core there. We have the different types of RAN access, whether it's emulator, whether it's access point, whether it's ORAN installation, they all attached to our core. In between, we actually integrated a traffic controller to replicate the impact of the transport network or the fiber, because our goal was always and still to support end-to-end testing. So we had to emulate this transport network. So we developed our own traffic controller that sits there between the RAN and the core. Overall, we also have orchestrated platform. So we work with third party who provide us with an orchestrator. So we support the slicing, we support the scalability. We can pass the data on a real time to see the traffic change, and we can scale up or scale down the platform. We can instantiate the slices. We have also our own monitoring tool that capture the data from across the network element and predict or show the real-time stats and the performance using the Grafana tool. At the same time, we integrated a third-party element which has hundreds and thousands of use cases pre-configured that you could launch them and use them and configure them. So you don't actually to start from scratch and try to replicate an IoT use case that is also available. So if you want to access the platform, we simply will sign you in, and we could also provide you with a trial period. and you can access the platform from your location. It's most of the elements, again, are available on Amazon. So we will create your own cluster that you use it yourself with your company, with your team. If you want to share that cluster with other partners, then this is something that we could handle as well. So your elements are kept for you. You are the one who govern them and access them. You can attach them to your physical IoT devices or physical access points, to your premises in the company. Use that cluster for yourself. If you want to open it to the public, that's your choice. But on the long run, or maybe on the midterm run, we will have our own shared branch. So if you want to test using your own cluster, you are most welcome. With your own partners, you are most welcome. If you wanted to open up to the wide society and release that to the open community, then we will have the shared branch where you can handle this later on. The platform that we have can support multiple use cases, multiple slices, not just the typical use cases that you see here, but also we have the ability to support security testing, emergency communications. We have plenty of other scenarios that we support at the moment, and we are happy to discuss this with each one of you on the side. So the way that we see the value of this platform to the wide society, it's a platform for testing, so you can test in an economic way using whether standard 3GPP elements, or maybe you want to adjust something out of the standard. You can still do it easily because this is based on open source. It's a platform for experimentation. You can come up with ideas. You can include new elements. You can integrate them. It's still CI/CD platform. We can develop it. We can adjust it. We can configure it based on discussions or based on the backlog that we create with the partners in this project. It's a platform for collaboration, so you can collaborate with any companies from across the world, or maybe with your partners across the border, because this is a shared cluster over the cloud. You don't need to take the hassle of allowing them to access your platform at your company premises. You can use the IEEE Testbed. We are neutral, we are open, and at the same time, whatever you share there is continue to be secure and supported and governed by IEEE rules. Showcasing, you don't need to go anymore and look for partners or customers. You can put your elements there and provide them with access to see your products or maybe your new features. And at the same time, this is a platform based on open source. It has the most ever recent network elements, so it could help you to define the new components that we could integrate or change the behavior, hopefully to define the network of the next generation and 6G. As we talk with different partners from across the globe, we found that we could actually become a hub for exchanging traffic and connecting multiple testbeds. That's one of the advantages of this platform, and being IEEE and neutral and available across the globe. So we see ourselves as part of this federated ad hoc testbed model. That's why we actually already started work to integrate with the IEEE 5G, 6G Center in Surrey University in the UK, with Eurocom in France, with 6G flagship in Finland, with 6G Life Center in Germany, with Eurocom again in France, with Johns Hopkins University. We also have access to the IEEE data port. I'm going to talk about it in a bit. We also have different partnerships with other companies that are not shown on this slide, but we are happy again to discuss with you, where we see that we could become the hub again for exchanging traffic, for leveraging new test use cases, and also to have this vision of creating traffic at one testbed and hopefully transfer that traffic to something else and see what could be the best use cases or testing features that we allow our partners to access them. With this, we actually partner also with the IEEE data port. So people who are testing nowadays, they put their data on the data port. They put their different use cases on the data port. And it has been always a concern for different people how to secure the data, where to get the data they can use for testing, or maybe where to save the data after they test. And the IEEE data port is a perfect repository for either passing the data from previous use cases and use them to your platform or to your cluster to test, or even to store your data and make them available or publish them. either as papers or as references, or either to keep them as data. So that's something that we worked on it with the IEEE Data Port team. So the key advantages in general would be accelerating the time to the market. You don't need to wait for your time to test or maybe to find the right resources to test. The IEEE test platform could provide you with massive availability and also with a lot of test case scenarios that are already available and valid, where you can validate and test your element or feature and make it available, or product and make it available to the customers. Foster innovation, since we are able to adjust and transform those elements. It's actually help you to leverage and develop new innovative solutions. It also help you to optimize the return of investment. So whatever you are investing here, you will see the value of it later on. And by the end of the day, we all want to contribute to the network of the future, hopefully define new standards, define new approaches, new functionality. And that's exactly the right venue to do it with the IEEE Testbed platform. Having this been said, the testbed has different capabilities as we talk today. We developed them already, like TBDK for the UPF integration, the video streaming, the private 5G, the cloud orchestration, Camara API, which we added most recently, and we made it available, multi-cluster orchestration. This platform is built with the best ever agile process as any other company, even though it's governed by IEEE, but actually we use a third-party tech vendor team to help us in the integration. So we build it as an industrial platform, and we are making it available to the wide society. However, as we move forward, we want to add new use cases like machine learning, dynamic network slicing, voice over NR, different features, but this list is not final. We are happy to discuss it with partners, just our backlog or roadmap based on the discussions, hopefully to serve as much as we can from the wide community of industry and academia. Just to give you a hint of what we are doing here, I'm not going to run those videos, obviously, but what I want to say is that we have the CLI access, similar to any platform for industry, but at the same time, we developed our own dashboard, web-based dashboard, which help you to ease and remove the hassle of accessing this platform, especially for academic partners. But also we have different dashboards coming from that platform that support different use cases, and we have a dashboard for the governor monitoring tool. We try to unify them to make it more easier for people to get all the data on a single access. At the same time, we demonstrated in the Mobile World Congress back in February that we are able to make calls using our own access points that basically direct calls from those phones to the core that sits on the cloud. And you could see, instead of having an operator, we have the IEEE testbed there. So we demonstrate that you can create a whole network here, again, of IEEE, but we are not competing with anyone. This is just meant for testing. It's a mini network. And finally, we have the physical layer access, or the access points. This is an example of the dashboard that we have here that shows you different data, where you can not just monitor the performance of the network, but you can also see the resource consumption based on the different test use cases that you run on the cloud, which help you to understand actually what's your operational cost and what is maybe even the power expenditure later on. Just to finalize this presentation, we want people to come and use it. Hopefully, we can support as much as we can from companies to leverage new business, new opportunities, and new functionality using this platform. We are hopeful to get manufacturers and providers and companies and everyone to work together, not just to innovate, but also to develop real products that could help the market to recover and accelerate the time for people to use those elements and make them available. This is a platform that's available 24/7. We support it. We have all the team assembled, ready to support you in the integration and the resource that you need. and also to create features later on as we move forward. This is the project team that worked on this platform since day one. So Ashutosh, myself, Brad Closa is the point of contact if you are willing to sign into this platform. We also have a product manager that we recruited. And again, we have a company that supports this integration on the back end. We also have a webpage that is available for people who want to get more information. Just by Googling this name, you will find our webpage very easily. There's a form also that you could fill there if you want to have a trial period or maybe sign to the platform. Thank you.
Thank you, Anwer. Let's give a big hand. And also, you might have seen Brad Cloja, who is present here, is the program director. There is a booth with some promotional materials. If you'd like to know more about Testbed, how do you like to get involved? I know there are a few more interesting talks around Testbed. So this is just one of the initiatives from within IEEE